All right, so here we go. Take out a piece of paper. Yeah, this is not one of your sheets. I'm sorry. We're going to do some random review because we have learned a lot and we need to recap.
It's bad.
Alright, here are the matrices we're going to use.
Is this homework?
No, this is practice. We are reviewing.
Is it good? It looks good.
Alright, here we go. These are the matrices we're going to be using, and I'm just going to ask you some questions about them. So the first question I'm going to ask you is this. Alright, this is review, so here we go. First of all, what's the rule for adding? You can't always add. It has to be the same size. So this is a 2 by 2. And this one is a 2 by 2, so guess what?
It's perfect.
We can add. So here we go. First number will be a 0, 3, 3, 9. Is that right? That's easy. All right, how about this? What's that going to equal? So we're going to find C. Here's C. So negative 2, 2, 4. Perfect. We just took everything in C and times it by 2. What do we call 2, by the way? Vocabulary word? Scalar. It's called a scalar. Remember, we have our special vocabulary. It's called a scalar. All right? What about this?
Multiply A times C, which you can.
We're going to multiply A times C. Now, A is a 2 by 2. And C is a 2 by 3. Can a 2 by 2 and a 2 by 3 be multiplied? Yes, because the rule is these match. Okay?
I was about to say, what if it's a C times A?
C times A would not work because then you'd have a 2 by 3 and a 2 by 2, and that does not work. But A times C will work. And when we multiply them, these dimensions tell me how big the answer is. So it's going to have 2 rows and 3 columns. Now, do you remember how to get this spot right here? It is row 1, column 1. So we take row 1 numbers and column 1 numbers, and we multiply them and add them. So we end up with just a -1 in that first spot. Then we go to over here, maybe. Order doesn't matter. I'll just go here, which is row 1, column 2. So row 1, column 2. And I'm going to multiply and add. So what do I come up with?
3.
I come up with 3. Okay? Now, row 1, column 3. So here's the row 1 numbers. Here's the column 3 numbers. I'm going to add them up and I get 8. Everybody remembering this? All right, let's see if you can fill in the bottom row. You're going to do the same thing, but now you're using row 2. So what do you get? -3, very good. 8, very good. And 21. Now, for those of you, let's just run through one of those. Let's say you maybe didn't, how do you get that 21, Mrs. Ford? Well, that's the second row and the third column. So I multiply the individual numbers and add them together. 6 plus 15 is 21. All right. How about this? Uh-oh. What's DET stand for? Determinant. So the determinant, remember, is the same numbers, but we put them in the absolute value symbol. So how does that work? Do you remember? 1 times 5. You multiply these two together. 2 times 3. And then you subtract them. Always subtract them. So it's going to be 5 minus 6. The answer to the problem is -1. What are you doing on your iPad?
3?
Yeah. Put it away. Shut it down. Yeah. We don't need it. Right now. Yeah. We're reviewing. Pay attention. Okay. Now, what about the determinant of D? Who remembers how to find the determinant of one that's that big? Do you remember, like Ellie says, we rewrite the first 2 columns? So these columns right here get rewritten right here. All right, and then what? We multiply. And where do we always start? With the very first number we wrote down. Always start with the very first number you wrote down. So multiply. 5. Multiply. 0. Multiply. 0. Total them up. We get 5. You are not done. Go back the other way. What do you get? -4. -1. 0. What does that add up to? -5? Now, whoa. What do I do with those 2 numbers? What do I do with my diagonals here? It's this one minus this one. So it's 5 minus -5, which is not 0. That's 10. Right? So we do all of these diagonals and get the total number. Then we do all of these diagonals and get the total number. Then we subtract. Okay? All right, one more review problem. Who remembers how to do this? This matrix B right here. Who remembers how to do the inverse? That means the inverse of B. Alex?
So you plug that, so it's going to be 4.
I'm going to make a new matrix. and I take these two guys right here and flip them. So the 4, like you said, will go here, and the -1 goes here. And 0 just stays 0, but the +1 becomes a -1. Is that it? I think there's another piece to it. That is exactly correct.
Yeah.
But this is a 2-step problem. Anybody remember the other step? 1 over the determinant. Remember how you get fractions? Because you're going to multiply this by 1 over its determinant. What is the determinant of this matrix? Multiply, multiply, subtract. So it's -4 minus 0, just -4. So now we take each of Alex's numbers here and multiply it by -1/4. So what's 4 times -1/4? -1. +1/4. 0. +1/4. And that is your inverse. So, make a special note there on the paper to remind yourself that finding the inverse is a 2-step process. You gotta do 1 over the determinant, and then multiply it by that new matrix Alex built by switching these and changing the signs on those. Okay? All right, so gather up everything, because you won't be coming back here. You'll be going, let me make sure I got my time right.
We're not coming back.
So you're not coming back here. You're going to lunch now. Gather everything up.